All right, so from 5-1 and 5-2 with that big set of reference box that we filled in, okay? Whether or not you'll give it, and you'll know by tomorrow, you'll know by 3:30 today, what you're going to get. If you know some of this stuff off the top of your head, obviously it's going to move faster. So my advice is to make sure that, especially the easy stuff that you know, like the reciprocal functions. What's the reciprocal of secant? 1 over cosine. What's the reciprocal of cosecant? 1 over sine. What's the reciprocal of cotangent? 1 over tangent. And then write tangent and cotangent in terms of sine and cosine. So what's tangent? Sine over cosine. And cotangent? Cosine over sine. You don't want to waste time having to find that on your reference sheet. It will take you forever to take this test. You won't finish it. The stuff that you can know off the top of your head, the better you're going to be. All right, so then the cofunctions. The cofunction for sine is what? Cosine. So the cosine of x is the same thing as sine of pi minus 2, or pi over 2 minus x. Meaning that if I drew a triangle, and I had x here, and then I had 90 minus x, which is pi over 2 minus x here, the sine of one is going to equal the cosine of the other. And these are interchangeable. So I could say the cosine of pi over 2 minus x equals sine. Secant matches with what? Cosecant. And tangent matches cotangent. So again, the more you know of these, the easier it's going to be. Even in odd, and we've been doing these for a little while, there are 2 things that don't change. So 2 of the functions that don't change are cosine and secant. So this comes from, if you think about like this first quadrant, right? So if this is positive pi over 6 and this is negative pi over 6. And the point here is root 3 over 2 and 1/2. And the point here is root 3 over 2 and negative 1/2. So if I asked you for the sine at pi over 6, you'd tell me it's what? 1/2. If I asked you for the sine of negative pi over 6, it's what? Negative 1/2. It changes, yes? If I asked you for the tangent at pi over 6, which is root 3 over 3, and then I asked you for the tangent of negative pi over 6, it's negative root 3 over 3. And because those change, the reciprocals are going to change. What doesn't change is the x, right? If I ask you for the cosine at pi over 6, you tell me it's what? Root 3 over 2. What's the cosine at negative pi over 6? Root 3 over 2. So note that the positive negative sign doesn't change. That's where even and odd functions come from. So the negative on sine, cosecant, tangent, and cotangent change the value of the function or the sign on the function. But the negative on the cosine and the secant do not change. Okay, and then the Pythagorean identities, and remember there's 3 of them. The first one that we know the best is what? Sine squared plus cosine squared equals 1. Okay, if I don't know the other ones, then I can derive them. So if I divide everything by cosine, I'd get tangent squared plus 1 equals secant squared. If I take the original and I divide them all by sine, I get 1 plus cotangent squared equals cosecant squared. And again, the better you know those, the less time you're going to be, if they are in your reference sheet, flipping back and forth between them. Okay, so in 5-1, you'd get something like this, but the right side would be gone. It would just be a blank. In 5-2, they would look like this, where it gives you your goal. So you're working your left side to equal the right side. And everything you need to know in order to do these is on that last slide we just talked about. So let's look at this and see how many we can do. And my advice is to just keep trying them. Eventually you're going to get to know these trig identities or Pythagorean identities, and you'll be able to fill these out easier. So if I have 1 plus tangent squared times cosine squared equals secant squared, what's something that I can replace? 1 plus tangent squared is the same thing as what? Secant squared. Now what? You can divide both sides by secant. Or you can change secant. So you could do it either way. Both ways you just said that would work. So 1 over cosine squared times cosine. Cancel out one of my cosines on the left-hand side. And I'd get 1 over cosine theta equals secant theta, and 1 over cosine is secant. So remember, there's not only one way to do these. You need that last step. So if you get to the second to last step and leave it, you will lose points. Make sure that you get all the way to the bottom and make sure you show the steps in between. You cannot get credit by shooting straight to the bottom. I know that you know that that's the answer. Now you got to show me how to get there.
Does it matter which side we flip?
No, you can work either side, and that's why these will take a little bit longer to grade than typical tests. You can work either side. As long as your steps are correct and your end match, you're good. Okay, let's look at the next one. Sure. All right, so it says cosine to the third plus sine squared times cosine equals cosine. Take out a cosine. So cosine theta would leave cosine squared plus sine squared. Now what? Cosine plus, or cosine squared, sorry, plus sine squared is 1. And then cosine equals cosine. All right, so who thinks they could start us off on this one? Go ahead, Alex.
You split up.
Which one? The left side? Okay, so you're splitting the left, so it'd be sine of x over cosine plus 1 over cosine. And then sine over cosine is what? And 1 plus cosine is? I would say they're not any easier than this. They're around this. So the funny thing is, somebody might have seen that and totally freaked out. So you view things differently than everybody else. So for somebody, that's super easy. And for somebody else, that's medium challenge, okay, moderate challenge, I would say something like that. They are not impossible by any means. Yeah. Yeah, so if you had, who would have done split the right side first? Or, okay, so let's do that one. So if I had worked with the right side, I would have gotten sine of x over cosine of x plus 1 over cosine. And then they both have the same denominator, right? So totally different way to do it. Both correct. Okay, so 5-3 was finding your solutions. So for this, you'll have your unit circle, okay? You want to remember the stuff at the top. If there's no interval given, then you have to make sure that you add 2 pi k to sine and cosine answers and pi k to tangent answers. And you have to restrict your interval for tangent of negative pi over 2 to positive pi over 2. If there is an interval, it will be like 0 to 2 pi. Then you use the entire circle for sine and cosine, but you don't add the 2 pi k. And you use your entire circle for tangent. You do not restrict it. So what I would probably do when I got the unit circle is add on the tangent measurement. So this would be root 3 over 3, 1, root 3, and this is 0. And then it would be the same down here. If I'm not on an interval, this would be negative pi over 6, negative pi over 4, and negative pi over 3. And this would be negative root 3 over 3, negative 1, and negative root 3. So because this is not restricted to 0, from 0 to 2 pi, I need to make sure that I add on, and it's cosine, so I'm going to add on 2 pi k at the end. So I want to solve for cosine. I would add the 3, divide by 4, and square root. This would be plus and minus the square root of 3 over 2. So then I go to my unit circle, and I find everywhere my x is root 3 over 2, because it says positive or negative. So my answers are all the over 6's. Pi over 6 plus 2 pi k, 5 pi over 6 plus 2 pi k, 7 pi over 6 plus 2 pi k, and 11 pi over 6 plus 2 pi k. All right, 3 tangent of x plus 2 equals tangent of x. I want to do the same thing. I want to work, this time I've got to work to get tangent on the side by itself. So you should remember that if it's tangent, that I'm only using the right side, and it's pi over 6, pi over 4, pi over 3, and then negative pi over 6, negative pi over 4, negative pi over 3. And for tangent, I add pi k, or nk, same thing. So the first thing I want to do is work so that the tangents are on the same side, so I can move 3 tangent of x from the left to the right, subtract 3 tan x. I get 2 equals negative 2 tangent of x, and then divide by negative 2, and I get the tangent of x is negative 1. So where on the unit circle is tangent negative 1? Somebody said it. What was it? Negative pi over 4, okay? And I would add to this pi k. Okay, so then the directions change. It says the following exercises involve equations with multiple angles. Solve each equation on the interval of 0 to 2 pi. These get to be a little trickier because you're not just looking for where the sine is 1/2, but then you have to do work with that answer. So I would first, it's already solved, I don't have to do anything. I'm looking for where the sine is 1/2. So it's positive, right, because it's got to be y, and it'd be at pi over 6. And 5 pi over 6, that's where sine would be 1/2. But instead of just saying x equals those, I'm saying 2x equals those. Pi over 6 and 5 pi over 6. And this is where they get a little tricky. They are restricting your domain here, but because we're altering what x is, you have to make sure that you add it on here now, because when I go to solve for x, it's going to impact the 2 pi k as well, and I'll show you what that means. So if I want to solve for x, I would divide both sides by 2. Which is going to give me, multiply by 1/2 here, pi over 12, which is one of my answers. But then the interval is every pi k after that. And again, I'll show you what that means. And then on the right side, I would get x equals times 1/2, 5 pi over 12, which is the solution, plus pi k. So normally I'd add 2 pi k, which would take me all the way around the circle, which brings me outside of my 0 to 2 pi range. But because I'm altering that 2 pi k, I have additional answers here. My answers are pi over 12 plus pi, and I have to see if that falls within my range of 0 to 2 pi. So if I take the pi over 12, and I add pi to it, which becomes 12 pi over 12, I get 13 pi over 12. Is that less than 2 pi? Is 13 over 12 less than 2?
Yes.
So I have another answer. And if I did the same thing on the right side, 5 pi over 12 plus pi, which is 12 pi over 12, I get 17 pi over 12. Is that less than 2 pi? So I have another answer. Now if I kept going, if I had taken 13 pi over 12 and added 12 pi over 12, because that's another pi, I get 25 pi over 12. Is that less than 2 pi? No, so I'm done. But I did add 2 solutions on to my initial answers. So when you're doing multiple angles, and let that be the key for you, the directions will say multiple angles, okay? You find your angles plus the 2 pi k or the pi k if it's tangent, and then you want to solve for x and see if you can keep adding whatever that 2 pi k over what you're dividing by would be. In this case it was pi, so I had additional answers. I'm going to do another one, okay? Okay, so let's follow the same set of directions, and I know it's different. Even without looking at my directions, I know it's different because that's not just x there. It's got something attached to it. Whether it's a multiplication or a division, there's something there that tells me it's not just my straightforward answer. So if I was to solve for sine, I would get sine of 3x equals negative 1/2. Now I'm looking for where sine's negative 1/2, which happens at 11 pi over 6 and 7 pi over 6. So 3x equals 7 pi over 6 plus 2 pi k, and 3x equals 11 pi over 6 plus 2 pi k. Now to get x alone, I have to do what? Divide by 3. So that's the same thing as multiplying by a third. So 7 pi over 18 plus 2/3 pi. 11 pi over 18 plus 2/3 pi. So now this answer is happening at 7 pi over 18 and every 2/3 pi after that. So these are my original points. These are definitely answers. They're in my range of 0 to 2 pi. But now I'm going to see if I can add on additional answers by adding 2 pi over 3 to both. So this, I multiply by 6. This becomes 12 over 18. 19 pi over 18. Is that less than 2 pi?
Yes.
Yes. So I have another answer. And then over here, I have to multiply by 6. So this would be 12, 18, 23 pi over 18. Less than 2 pi? Yes. Now if I were to add on another 12 pi over 18, I get 31 pi over 18. Is that smaller than 2 pi? What's 18 times 2?
Yeah, no, it is.
Yeah. And if I add 12 pi over 18 here, I get 35 pi over 18. Less than 2 pi? Yeah. So I have an additional answer. So I keep going. Now if I add 12 pi again, I end up with 43 pi, which is bigger. 43 over 18 is bigger than 2. So you want to keep adding your adjusted interval until you hit 2 pi or something bigger than 2 pi. Then it gets easier. The following exercises involve the trig equations in a quadratic form. Solve each on an interval. All that means is that there's a squared in there, okay? So I'm going to do the same thing I did, but this time I have an interval of 0 to 2 pi, so I don't have to add my 2 pi k. So I would get 4 sine squared x equals 1. Divide by 4. Sine squared x equals 1/4. Square root, making sure I put a plus and minus in the front. And I get plus and minus 1/2. And it's all of my over 6's. Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So it gets worse before it gets better. Okay? This next example says to use an identity to solve the equation. 2 sine squared x plus cosine minus 1. So the fact that it says identity is hinting to you to use your reference sheet. And then if I look, there's a sine and there's a cosine. So I've got to replace one so that they'd be the same functions. And since sine squared is in sine squared plus cosine squared equals 1, if I wanted to solve for sine, I would say that sine squared equals 1 minus cosine squared. So if I take that and I plug it in the place of sine, I get 2 1 minus cosine squared x plus cosine x minus 1 equals 0. This should be that 2 minus 2 cosine squared x plus cosine x minus 1 equals 0. Combine your like terms, negative 2 cosine squared x plus cosine x. Positive 2, negative 1 is a positive 1. Now, as soon as I see the squared and the non-squared, I know I'm going to have to factor. As if this was negative 2x squared plus x plus 1. It would be negative 2x and positive x. And then the factors of positive 1, and positive 1 would tell you that this was negative 2 plus 1, which is negative 1. So that one doesn't work. Switch it so that this is negative 1 and negative 1, and now I get positive 2 minus 1, which gives me the positive 1x. So negative 2x minus 1, and then x minus 1. But this is cosine instead of x. Now I'll set each of these equal to 0. I'd get negative 2 cosine x equals 1, cosine x would equal negative 1/2, and then cosine of x would equal 1. So I want to go around my unit circle and find all the places where cosine is negative 1/2. So the x's are negative in the second and the third quadrant, and negative 1/2 is at your over 3. So this would be 2 pi over 3 and 5 pi over 3, and then it's positive 1 here at 0. So I'd get 0 plus 2 pi k, 2 pi over 3 plus 2 pi k, and 5 pi over 3 plus 2 pi k. Okay, so sum and difference formulas are where we started with the warm-up today, or sorry, with the review worksheet. So these will be on part 2 of the video, which we'll cover tomorrow.